Part 4. Simplifying algebraic expressions involving radicals. Okay, in this section you're going to have to learn to find something called restrictions on variables. This only happens when you have letters in your radical, okay? So, it's important to state any restrictions on the variable. Here are some scenarios you might encounter. It's important you state the restrictions with every simplification or solution. So every time you simplify, if you have letters under your root sign, you should tell what the restrictions are. And later on, we're going to be doing some solving. Same thing. Okay, so even exponents. The square root of all powers with even exponents is defined for all values of x, meaning that there are no restrictions if you have x squared, x to the fourth, x to the sixth, and so on, okay, underneath your root sign. So the domain would just be written as x belongs to reals. Okay, so if I had like 171 square root of x to the 100. Oops, so that's an x, not an 8. Okay, good. That, of course, would have no restrictions. X could be any number. Okay? But again, if I had an 8 under there, 8 to the 100, okay, there's no worries because 8 is just 8. It's not restricted. It's only 8. Okay, so only has to worry about it if there are letters. All right. Odd exponents. The square root of all powers with odd exponents, so 1, 3, 5, 7, 9, blah, 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 okay, is defined for values of x where x is greater than or equal to 0 and x belongs to reals. Now remember, this is when we are square rooting. If we're cube rooting, then it doesn't matter because you can cube root some positives or negatives, okay, but square rooting, you can only square root things that are positive. Okay, so again, square root of x, square root of 2x cubed, square root of negative x, square root of x to the fifth, all have radicands with odd exponents. There are restrictions, so the domain is always written as x is greater than or equal to 0, x belongs to reals. Okay, and again, that only works, you only have to worry about it if there's a letter under the root sign. Okay, and of course the infamous dividing by 0. We can't divide by 0. It's not possible to take something and make no groups. So 0 might have to be included in your restriction, but again, only when we have a variable in the denominator. So if we take a look at this example, we are dividing by root x. Now it's odd, so that means it can only be greater than or equal to 0, but again, if this is 0, square root of 0 is 0, 0 times 2 is 0, so that would make the whole thing 0. So an x in the denominator that is odd cannot be 0. And even if you have an x in the denominator that is even, it still can't be 0. So please make sure you notice the difference. So odd exponents, x is greater than 0, x belongs to reals, because we can't square root negatives and we can't square root 0 in the bottom. Okay? However, if it's even, we just have x can't be 0 because anything that is negative, so if we had x was negative 2, then that would be 4 over 2 root negative 2 squared. Well, when you square the negative 2, it becomes a positive, so then you can square root it. Okay? Okay, so restrictions, again, always stated, whether simplifying, performing an operation such as adding, subtracting, multiplying, dividing, or solving an equation. Let's do some examples. State the restrictions on the variable and then simplify. Okay, so x is even, so therefore there are no restrictions. X is not in the denominator, so again it can be 0. So we would just say that x belongs to reals. Okay, and simplify. So 45 is not a perfect square, but it is the product of 9 times 5. X to the fourth square rooted. Again, that's a perfect square, so we can square root it. So that becomes 2. Square root of 9 is 3. I cannot square root the 5. Square root of x to the fourth. Remember, when you're square rooting, just divide the exponent in half. So that becomes x squared. And the 5 had to stay. Okay, so 2 times 3 is 6, so 6x squared root 5. All right, next one. So in this case, we have x to the fifth, so that's an odd exponent. It's not in the denominator, so our domain then would be x must be greater than or equal to 0, x belongs to reals, which means x cannot be a negative number. Now let's simplify. So negative 3x is already outside, so it doesn't need to be simplified. Root 8 can be written as 4 times 2. Okay, and x to the 5th can be written as x to the 4th times x to the 1st. Okay, so remember that when we multiply things with the same base, we add the exponents, so 4 plus 1 would make the 5. The reason I did that is because x to the 4th is a perfect square, but x to the 1st isn't. So let's simplify. Negative 3x, square root of 4 is 2. I can't square root the 2. Square root of x to the 4th is x squared. I cannot square root x to the 1st. Okay, so what stayed underneath the root sign? 2x to the 1st. All right, so let's multiply the guys up front. So negative 3 times 2 is negative 6. X times x squared is x cubed. All right, let's go to the next page. State any restrictions on the variable and then simplify. So basically the same as the last page. Okay, so in this case we have an odd x underneath the root sign. So there's no denominator, so x is greater than or equal to 0. X belongs to reals. Okay, and again we're subtracting, so we need to have same index, same radicand. My index is all square rooting, and my radicand is all 2x, so I can just subtract the coefficients. 15 take away 7 is 8, and 8 take away 1 is 7. So my answer here is 7 times 2 root x, and I cannot simplify 2 root x because I don't know if 2 is not a perfect square, and x doesn't seem to be either. Okay, part B. We have, again, odds, so x must be greater than 0, and again, there's no denominator, so greater than or equal to 0. X belongs to reals. And now we are multiplying, so outsides times outsides, insides times insides. So 5x cubed times 1 stays 5x cubed. Root x times 2x, root of 2x cubed, so 1 times 2 is 2. X times x cubed is x to the 4th, because again, we add the exponents. X is x to the 1st, okay? Times x to the 3rd would make x to the 4th. Now, that does give us a perfect square under the root sign, so the square root of x to the 4th is x squared. So 5x cubed times x squared, and again, the 2 is not a perfect square, so it stays under the root sign, and that gives us 5x to the 5th root 2, because again, multiplying x cubed by x squared, we add the exponents. All right. Next example, divide the coefficients. Oh, before we do that though, we need to do the restrictions. So we have odd numbers, so x cannot be negative, and we also have an x in the denominator, so x cannot be 0. So my domain then is x has to be greater than 0. X belongs to reals. Okay, now we can divide. So coefficients divide by coefficients, radicands by radicands. So negative 36 divided by 12 is negative 3, square root. X cubed divided by x becomes x squared. Okay, now again, I have a square root of a squared, so I can simplify that. That gives me negative 3. The square root of x squared is just x. Example D. We have odd radicands, but we don't have any divided radicands, so that would just give us x must be greater than or equal to 0. X belongs to reals. Okay, so again, we're just going to take this monomial and multiply it in to the binomial. So outsides by outsides, so 2x times 1 is 2x. Square root of x times square root of x is square root of x squared. Plus 2x times 4 is 8x. Square root of x times the square root of x to the 5th makes the square root of x to the 6th, not 8. Seem to have a problem with that today. X to the 6th. Okay, good. I can square root x squared because it's a perfect square, so that becomes 2x. The square root of x squared is just x. Plus 8x, and again, x to the 6th is a perfect square because it's an even exponent, so that becomes x to the 3. Again, just divide the exponent in half. 2x times x makes 2x squared, plus 8x times x cubed is 8x to the 4th. All right, next one. Well, I don't have any x's, so therefore there are no restrictions. I can just multiply away. So 2 root 3 times root 3, and so outers, inners, firsts, and lasts. foil it up. So, again, no restrictions. You can even write that if you want, so that you remember, because there are no variables. All right, so 2 root 3 times root 3 becomes 2 root 9. 2 root 3 times 3 root 5 is plus 6 root 15. That's a negative 5, so negative 5 times 3 is negative root 15. And negative 5 times positive 3 root 5 becomes negative. Positive times a negative is a negative. And 3 root 25. Okay, so 9 is a perfect square, so that becomes 2 times 3. 6 root 15 minus root 15, those of course are like terms. So subtract the coefficients, that would give me positive 5 root 15. Okay, and minus 25 is a perfect square, so that becomes 3 times 5. Okay, 2 root times 3 is 6, plus 5 root 15 minus 15, because again 3 times 5 is 15. So that would give us 5 root 15. 6 take away 15 is negative 9. Okay, last but not least, 3 minus x over root x. So, because we have x that's odd and x in the denominator, x must be greater than 0. X belongs to reals, because we can't square root negatives and we can't divide by 0. Now what I'm going to do in this case is rationalize, so that gives me root x over root x. Okay, and so that would give me, again, we have to FOIL because it's a monomial times a binomial. So we have 3 root x minus x root x all over x times x is x squared. So square root of x squared. So we would have 3 root x minus x root x all over x. Okay, good. You could simplify that a little bit, I guess. You can also write it as 3 root x over x minus these x's would cancel, so minus just root x. Either one I would accept to be correct. Okay, great. This is some good time to practice. So page 211, 2-3, 5A6, 8AC, 9BD, 10BC, 11AD. Show your teacher when you have completed this.